Good day, everyone. We are Group 3, and we will discuss to you the experiment on the analysis of viscosity of fluids. In this experiment, we used virtual laboratory to examine the viscosity of three fluids, which are water, kerosene, and alcohol. Theory. Viscosity is an ability of a fluid to have a resistance on the formation of its shape and form at a given rate. In the process, there are a study which concerns about the interpretation of the fluid's viscosity. So the formula of viscosity, N is equal to 2R squared times rho sub 2 minus rho sub 1 G over 9V, where R represents the radius, G represents the gravitational acceleration, rho represents the density, and V represents for velocity.
For our objectives, first is to determine the viscosity of each fluid by utilizing the experiment and its concepts. Next is to maximize the usefulness of the experiment to have a further achievement in determining the viscosity. Our materials to be used are liquid, ball, stopwatch, graduated cylinder or jar, and also the Microsoft Excel. And in order to properly achieve the objectives of this experiment, the following procedure should be considered. Using virtual labs, select the liquid from the drop down. Select the material of ball from the drop down and enter ball radius between 10 cm to 35 cm. Next is click on submit button. Drag the ball to the top of the jar. Note the distance appearing in the information box and time in the stopwatch, and note down this distance and the time in the data table. Number 8 is to repeat the experiment for different values of the distance. When the table is completely filled, click on plot to get the graph. Next is to calculate the slope of the graph and also enter the value of the calculated viscosity in the enter viscosity box. Number 12 is click on percentage error to calculate the error in the calculated value of viscosity. And lastly, repeat the experiment for different liquids and different materials of the balls.
So next is the observations and calculations. Viscosity is an ability of a fluid to have a resistance on deformation of each shape and form at a given rate. So the working formula used by our group is from the theory is viscosity is equal to 2 over 9 r squared times density density 2 or rho 2 minus rho 1 times g all over v. So our group conducted three experiments in the virtual laboratory. The first experiment consists of water. The known values of water from the virtual laboratory is the density of water equals 997 kilogram over meter cube. The density of stone 1,602 kilogram over meter cube, and the radius of the stone is 20 centimeter. From the results of the experiment, um, the data table is presented. The distance and the fall time of the stone. The experiment for the water is conducted um, for 5 trials. For the first trial, the distance is 43 cm. The fall time is 5.62 seconds. For the second trial, 44 cm, and the fall time is 5.55 seconds. And the next one is 45 cm, and the fall time is 5.26 seconds. And the fourth one is 44 cm and 5.52 seconds, and 46 cm, 5.61 seconds. So, presented is um, the distance and time of water and stone plotted in the graph. So, for the manual computation, for trial 1, trial 2, trial 3, trial 4, and trial 5, um, um, can be observed that that we use the formula from the theory 2 over 9 times the radius given, which is 20 cm, times the density of the stone minus the density of the water times gravitational acceleration all over um, the distance and over the fall time. So the next one is for the kerosene. The known values are density of kerosene, which is 795 kilogram all over meter cube. The density of the stone, which is the same, 1,602 kilogram over meter cube. And the radius we used is also the same, 20 centimeter. Below is presented is the data table for the kerosene for 5 trials. The first trial, having 44 having a distance of 44 cm, fall time of 5.61 seconds. Second trial, 45 cm, 5.63 seconds. 43 cm, 5.65 seconds. The fourth trial is 44 cm, 5.76 seconds. And the last, or the fifth trial for kerosene is 45 cm and the fall time of 5.52 seconds. So the graph for the distance and time of kerosene and stone. For the manual computation, for trial 1 to 5, we also use the formula 2 over 9 times r squared times rho 2 minus rho 1 times dl over v. And lastly, for the alcohol, the known values are density of alcohol, 803 kilogram per meter cube. The density of the stone is the same, and the radius we used also the same. For the data table, um, for trial 1 to 5, the first trial gathered 5.62 seconds of fall time with 45 cm distance. Second trial of 44 cm with 5.65 seconds. Third trial is 46 cm, 5.61 seconds. And the fourth trial is 45 cm with 5.63 seconds. And the last trial or the fifth trial is 55 cm with 5.42 seconds. We also graph the distance and time of alcohol and stone as presented. For the manual computation, trial 1 to 5, we also use the formula from the theory. So for the self-evaluation, for number 1, the question is, what is the relevance of assessing the liquid's viscosity? So for our answer, viscosity is an important property of fluid. According to an article by Morse 2018, it is defined as the internal friction of a fluid or its ability to resist flow. This means that the viscosity of a product must be controlled and measured in production so that each batch is consistent from day to day. Knowing the viscosity of a certain liquid can help in determining the parameters required in order to process it. Hence, the machine type and the pipe to be used can be determined depending on the viscosity. Once the proper pipe is determined, the processing of the liquid will be more efficient. So for the second question, is there a difference in the accuracy of measurements of the reading if the units used vary? Yes, there will be a difference since unit is very crucial in assessing the accuracy of the measurement since wrong unit can result to a larger percentage error from the true value. The lower the percentage error, the more precise the measurement can be.
How can you reduce the viscosity of a liquid? Unfortunately, to date, there are no effective methods to reduce the viscosity of liquids, suspensions, except by changing the temperature. Next, what is the importance of laboratory rules and safety? The purpose of this is to help the lab students to understand proper laboratory safety, to increase their awareness of the possible risks or hazards involved with laboratory work, and to realize the laboratory is generally a safe place to work if safety guidelines are properly followed. Fifth, do you think the experiments required observations and computations to be reasonable or complicated? Why? It is reasonable since the students followed the procedure and the theory provided. Also, the concept of viscosity was already presented to us in our former years of education, and we have prior knowledge about it. The observations and computations provided are based on our understanding and from the gathered data from the simulation of the virtual laboratory. And lastly, why is finding the liquid's viscosity important in engineering? Engineering is always leaning toward work related in the industry, such as food processing. Viscosity can be an application of fluid food processing, and having knowledge and information about it can reduce the error to be made. For the safety reminders, the following are some important safety reminders for laboratory experiments. Number 1, wear personal protective equipment. Second, clean apparatus. Third, calibrate the laboratory instrument. Fourth, avoid eating or drinking inside the laboratory. Fifth, don't perform experiments on your own. Sixth, read instructions, safety symbols, and hazard signs. And lastly, proper disposal of laboratory waste. For the reference,
That's all. Thank you.